Hey guys, here Word Physics, and today in my city we had a really bad storm. I will show you here. So maybe you can see a lot of clouds in the sky. So this storm made me remember when I was a kid, a friend told me that in a storm, when you hear a thunder, you can actually count how many seconds between the thunder and the lightning happen, and those seconds will represent how far the lightning was from you, and each second represents 1 mile or 1 kilometer. But I'm not sure if this is true, and I know physics and I know maths, so I thought, well, I can actually verify if this statement is true or false. So today I wanted to show you my work about if it is true or false that you can count the seconds between a thunder and a lightning, and those seconds represent a mile each. So I hope you enjoyed this video, and I made two videos about this. I made a simple one and a more difficult one. The more difficult one incorporates more maths, so see the one you think it's good for you. I hope you enjoy, and see you next time.
Hey guys, so this is the second part of my video, how far is lightning from you? And this video will include some math, but they won't be really hard. I will explain them and I hope everything will be clear. So let's start with the situation. Here you have lightning, you, the distance between you and lightning, and here you have let's say the ray of light coming off, and here sound coming off of the lightning and thunder. So what you will see first, because what you will see first is the light coming from the lightning, because light travels way faster than sound, and then you're going to hear sound. So sound is traveling with a velocity vs, because velocity of sound, just to make things clear. Light is traveling with a velocity VL, velocity of light. Light has a time TL, time for light. Sound has a time TS, time for sound. And the time you can actually count and measure from the lightning, the light you see, to when you hear the sound will actually be T. We'll call it T3. Okay? T3. Okay. So from this situation, we're actually going to derive, how far is the lightning from you in relation to the time it takes for sound and light to get to you. So we know that T3, here I'll write it big. Oh, so you can see, here you go. We know that T3, here you go, T3 is equal to the time for sound to get to you. So TS minus the time light took from the thunder to you. So TL. So actually T3 is not only the time the sound came from the lightning to you, because you cannot measure the time the sound took from lightning to you. You can only measure the time sound took from when light came into you to when sound came into you. So there is a lap. There is the lap that you cannot measure. You cannot measure the time light took from the lightning to you, because you just saw light. There's no way you can know before. So we have this kind of equation relationship. Now we know that time, here, side note, velocity is equal to distance over time. So here, T3, we're just replacing some variables, is equal to Ts is distance, or d over velocity of sound, and not to confound with velocity of light, only velocity of sound. So Vs, here you go, minus TL, that is actually distance, and we know that the distance is the same, over velocity of light, so we will call VL. And we do not change T3 because it's the only variable we know here, well, except Vs and VL actually. But here in this equation we only know T3, so it's important we do not change it, because if we do change it, then we won't have a base. And here we're changing actually to velocities, so we have something we already know. Okay, side quote again. Here, the velocity of sound, I'll put it here, Vs is equal to, and there's a mathematical relationship with temperature, so it is 331 meters per second plus 0.606, sorry, here I have no more space, 0.606 multiplied by the temperature in degrees Celsius. Okay, so this is the relationship between speed of sound and temperature. So in my other video I actually used a fixed number, 341, for the speed of sound, but here you can actually calculate the speed of sound depending on the temperature you're at, so it will be different for everybody. Here now, coming back to this formula, we would like to put both of them in a single kind of equation, in a single number, or multiplication, or division. So what we have to do is find a common denominator between Vs and VL. Side note again. So if we take VL, that's the largest number between VL and Vs, VL, and we divide it by Vs, we will have something called, and I kind of invented this, how do you want to call it? Alpha? You want to call it alpha? Alpha? There's a lot of alphas, but here, that's going to be our alpha. So here you go. VL over Vs is equal to alpha. So actually, if you multiplied Vs by alpha, you're going to get VL. And we won't have VL here to have a common denominator. So instead of putting Vs, we are going to put, so let's put T3 is equal to D multiplied by alpha, and I will explain in 1 second, over Vs multiplied by alpha minus D VL. Good. Here, if we multiplied alpha at the bottom, we have to multiply alpha at the top. So alpha divided by alpha cancels out, and we have D over Vs. But we know that Vs alpha is actually VL here. So we're going to replace Vs alpha by VL. So T3 is equal to D alpha over VL minus d over VL. Here you go. And now we have a common denominator, so we can say that T3 is actually equal to d alpha minus d over VL. Oh, this is alpha. Yeah, I guess you kind of know where we're going, right? So now from this, we're going to put that T3 VL is equal to d alpha, and we have to remember that alpha is VL over VS, and that VS is 331 meters per second plus 0.606 multiplied by the temperature you're at. So T3 VL is equal to d alpha minus d. And now we're going to kind of take d out of this, and we have that. Finally, I will change it here. T3, or what we can measure, this is what the time we measure between light, or between when we see light and when we hear the sound. So T3 VL is equal to d multiplying alpha minus 1. Good. And then d is equal to, so now we're going to, because we're looking for d, so d is equal to, and I'll just like change sides, is equal to T3 VL divided by alpha minus 1. This is our equation. It's nice, right? So we know that the distance between the lightning, or where the lightning happened, and you is equal to the time you can measure between light and sound multiplied by the speed of light, that's a really huge number, divided by alpha, that's also a huge number. Well, it's not a huge number, but it's a number, it's a good number, minus 1. Okay, so thanks for watching, and I hope you subscribe. I hope you liked this video, because it was a good effort to find out and to actually do it. And I'm really sorry I couldn't upload it before, but I had some troubles, and I had camera troubles, and then it was all jiggly, but it doesn't matter now. And I hope I will be able to do some weekly videos, or at least one video every 2 weeks. And we're going to start things a little bit more complex. I hope so. So not a lot more complex, but special relativity and stuff like that. And yes, so I hope you enjoyed, and don't forget to subscribe. Watch my next video.